Hello friends, welcome to this channel. This is G Solutions. Today let us learn how resistors are connected in parallel or in series. Let us start first in series connection. Suppose I would like to draw a schematic diagram here for R sub 1, which is my resistor 1, and another resistor with a different value from R sub 1, name it as R sub 2, and another resistor, name it as R sub 3. To be able for us to know that these resistances are in series, we can observe that the current that is flowing all throughout these resistors are the same. So for end-to-end connection, it should be connected in different nodes. For R1, for instance, this is the right side node of R1. I'll connect R1 to the left node of R2. Okay, so the right node of R2 will be connected to the left node of R1. So it is different. It is connected differently from node to node. And when current pass through here, let us name this as I sub T for total current. The current that is passing through the resistor R1, let's say this is I sub 1, is the same as the total current. So we can set up equivalent. I sub T is equals to I sub 1, the current R sub 1. So also with R sub 2, the current here is I sub 2. I sub 2 is also equal to I sub T. So this is I sub T is equals to I sub 2. And also I sub 3 is equals to I sub T. So all throughout the current are the same, since R1, R2, and R3 are connected in series. For the total resistance, we can actually get another resistor equivalent to the values of R1, R2, R3 connected in series. So this can be represented by a single resistance with R sub T. Means this will be it means that this will be the total resistance or the total value of the resistors R1, R2, and R3. Since this is total resistance, the current that is feed through this resistance is I sub T. And R sub T has a value of the addition of all of these resistances. So R1 plus R2 plus R3. So if in case that you add here another resistor which has a specific value, it will just be an addition to these resistances. Okay, so that will be the value for RT. Now, using Ohm's law, it states that the voltage is equals to the current times the resistance. You can manipulate this formula. If you want to get current, you just have to divide the voltage by the resistance. Now if you want to get the resistance, you just have to divide the voltage by the current. So let's take for example the equation for the resistances RT. Now if we are to get the value of RT using the given value of voltage and current, it will be stated like this one. So V sub T over the current I sub t. So that will be your R sub t here. Now let's have the value for R sub 1 using Ohm's law. So again, this is B sub 1 over the current at R sub 1 is I sub 1. I use here B sub 1 for us to have a reference that the voltage that we are considering is the voltage of R sub 1. So also for R sub 2, that will be B sub 2 over I sub 2. And also for R3, we have here B sub 3, the voltage is here, over I sub 3. Okay, so this is an equation in which we use the other parameter of our circuit, but this is actually resistances. Now we know that the currents here are equal, so rewrite the equation B sub t over I t is equals to, instead of writing I sub 1, I will write I sub t. So this will become B sub 1 I sub t plus B sub 2 I sub t plus B sub 3 I sub t. Okay, so it means that we will be having a common factor here. The common factor is 1 over I sub t, and what remains inside the parentheses is B sub 1 plus B sub 2 plus B sub 3. So in our algebra, since that in both sides you have the same value, you can factor it out. So you factor this one and this one. So what remains is B sub t is equals to B sub 1 plus B sub 2 plus B sub 3. So we have here a relationship for the voltages of resistors in series. So in our drawing, this part is our V sub 1, and from this point to this point, different node, this will be your B sub 2, the voltage at R sub 2, and also the voltage at R sub 3, which is B sub 3. So therefore, the whole voltage here, okay, at this point, considering this point, let's say this is A and B, which is B A sub B, from point A to B, or the total voltage, is actually equal to the summation of the voltages, the voltage at R1 added to the voltage at R2, and also with R3. So this is the nature of a circuit connected, wherein the resistor is connected in series. So this is how we should understand series connection. In summary, the currents are the same. Yeah, it has an equal current, but the voltage are different. So to be able for us to get the total voltage, you should add each of the voltages of the resistors. Okay, so how about if it is connected in parallel? For instance, I have here R sub 1 and another resistor here, R sub 2, and another resistor, R sub 3. Okay, so currents are not the same here. Now, if we are to connect from end to end the nodes of our resistors, each node should be connected to the same node of the other resistors. For instance, this is my left node of R sub 1 and this is the left node of R sub 2, the left node of R sub 3. So it will be connected the same. And the right node will be connected also. And let us name this as points A and B. So as you can see, if we are to let current flow or pass through this point from A, I sub t, the behavior of this current is when it passes through this point, the current will divide. So some of the currents will flow to this branch, which is named as I sub 3, and some of the current will flow here, and also another current here, which is I sub 2, and the current will flow here for I sub 1. So to be able for us to get the total current in a parallel connected resistors, so the total current is actually the addition of all the currents that is passing through the branches. So that will be I sub 1, the current at R1 and I sub 2, and also the current at R sub 3. Now, how about the voltage? Considering B sub AB, points A and B, or node A and B, the voltage here is actually our total voltage. And B sub T is equals to B sub AB. So you'll notice that the voltage here for R sub 2 is B sub 3. It will be also equal to the total voltage of B sub AB, so B sub 3. So also with the voltage at R sub 2, which is B sub 2, is also equal. And also here, B sub 1 is also equal. So we can now have a comparison between the two connections, this one in series circuit and this one in parallel. So the voltage in this series connected resistors, the voltage are not the same. To get the total voltage, you have to add every voltages. But in our parallel connected resistors, the voltages are equal. But the current here is equal. The currents at R1, R2, R3 are the same. So here we have a different idea. The current here is the summation of the currents at R1, R2, and R3. So it will be added. So that is the difference between the two. How about the resistance? Now we can also use this equation to get the relationship of the resistances. By the way, as we have done in this connection, that this can be represented by a single resistor R sub T. So also with this parallel connected resistances, you can have also a resistor equivalent. Okay, I'll just place an arrow here to this parallel connected resistors and have it named as R sub T. By the way, this also is point A and point B as correspond to this circuit or this connections. Also with this one, this is A and this is B. So what is the value of B? So we use this one. Using this relationship and also Ohm's law, we can solve for actually the current by using the other variables, the voltage and the resistance. For the total current, okay, so by the way, the current here also is I sub T, and the voltage VAB here is actually B sub T. So we say that I sub T is B sub T over R sub T. which is equals to the voltage here. That will be V sub 1 over R sub 1 plus V sub 2 over R sub 2 plus V sub 3 over R sub 3. Okay? And let us further simplify, since that B sub 1, B sub 2, and B sub 3 are all equal, which is equals to B sub t. So, therefore, rewriting this equation, we have B sub t over RT. Okay, I am rewriting it now. This is B sub t R1 plus B sub t R2 plus B sub t R3. So we can factor out B sub t on the right side. So this is B sub t, and what remains inside the parentheses is 1 over R1 plus 1 over R2 plus 1 over R3. So this will be cancelled out. Okay? So therefore, we can now get B sub t. So we just apply here fractions, in which you will notice that you have here the LCD of R1, R2, and R3. So you have R1, R2, and R3. Okay, so now if you divide this one to this first term, R1 will be cancelled out. So R2 and R3 remains. In this term also, what remains is R1 and R3. And here, that will be R1 and R2. So therefore, we can rewrite this equation. RT, okay, cross multiply, so that will be R1, R2, R3 all over R2, R3, and just copying the numerator, it will now become the denominator. R3 plus R1 and R2. Okay, so this is it. So RT is this equation. This is equation for 3 resistances. So this is how you connect resistances in series. By the way, this is in series. Okay, I'm writing here series, and this one is in parallel. Okay, parallel. Okay, so that's it. So thank you.